Hello, my name is Edgar Valdez, and I'm a physicist and a technology business innovation consultant. Today, I'm going to talk about digital transformation, data quality, and its relation with machine learning directly on Mexico's context. On this presentation, first, we're going to talk about network orchestrator business models, which main feature is a wide-reaching and continuously evolving value proposition. Second, we will establish that digital transformation enters when reliable data and meaningful information became digital enablers of these networks. Moreover, machine learning increased knowledge on business purpose if high-quality data is used. Here, we describe four different industry use cases to demonstrate that Mexico's high-quality data increase the cost effectiveness. Finally, we conclude that the highly variable context from Mexico provides an ideal environment in which machine learning augments coordination between digital enablers and network orchestrators. Let's begin. What does Uber, Airbnb, and Alibaba have in common? Uber is a private transportation service company present in more than 311 cities in 58 countries that doesn't have a car fleet. Airbnb is a short-term lodging service that rents rooms to more than 200 million guests without owning a single hotel. Alibaba is a sales service of about $730,000 million that doesn't have a single store. At first glance, what these companies have in common may seem odd. They do not have a single administration, and they are not owners of anything. But there is an explanation that leads to the question: how knowledge generates digital services? Looking at 40 years of financial data from more than 500 companies analyzed by Deloitte shows that business models can be classified into four categories: manufacturing, services, technology, and network orchestrators. Uber, Airbnb, and Alibaba are orchestrators and base their business model on creating interactions. Interaction generates knowledge by two mechanisms. First, when the network is created, common wishes are simplified, generating far-reaching value propositions. Second, when new strong group is added to the network, new information and knowledge is fed to it. Let's put it this way. Value propositions are the gears of digital transformation, and the energy that moves them is information. Let's move forward. These days, the relation between global and technological trends does something very unusual. It establishes restriction in our interaction both among ourselves and with the environment. But at the same time, it leads to the creation of technological solutions totally different from what we had seen in the past. Let's focus on digitalization. From it comes something important, very important. Industry 4.0. What is this? First and foremost, it introduced the digital company, where information and the physical world are integrated in such a way that organization schemes, people, and assets now have a dynamic evolution. In relation to our subject, digitalization enters when the data generated over the element's interaction is used to amplify, regulate, or create information. When network orchestrators reach big scales, restrictions arising from the global become important. How does this work? Initially, harvest, storage, and transmission of data must be done in a reliable way, creating different types of technological platforms, such as data services, application services, processing services, and integration plus quality services. On the other hand, the root of all meaningful information is data interpretation or modeling. This means that as predictability increases, surprise decreases, establishing an amazing relation among the different platforms. Technology platforms and data models can be regarded as the key enablers of digital transformation. These days, machine learning techniques are excellent catalyzers because they make harvest transmission of data easier, cheaper, and faster. Also, data interpretation and accuracy can be boosted. But how can we use machine learning? We can use on classification, decision, and also on predictive arguments. Why can we use machine learning now? Because there are many pre-trained models on business purposes, and there is a more economical option of implementing them because there is more power on in-memory computing.
The impact of data quality to improve machine learning techniques has been acknowledged according to an IBM estimate, and this impact is a major one, roughly $3.1 trillion per year in the United States alone. For our study, we are focusing in the completeness, timeliness, and accuracy of data as key characteristics of high-quality data. On a survey made to 38 Mexican CEOs of various industries, they agree that it is possible to get complete and timely data, but accurate data can be very costly. We believe that working within rich economical ecosystem for data harvesting can improve machine learning performance. For this, we have prepared a minimal framework to study 4 use cases in Mexico's industry. Each industry sector has its own business processes managed with a specific set of digital enablers such as technological platforms and digital models. Improving business process tasks can be done with the aid of different machine learning techniques which act as catalyzers. Moreover, the economical and natural ecosystems sets the way in which business tasks can interact. On the analyzed cases, we see that improving the conditions in which information is produced has the potential to minimize the cost of accurate, complete, and timely data. Let's focus on 4 major sectors of the Mexican economy: oil and gas, logistics, agriculture, and manufacturing. Pemex, the main oil company in Mexico, is currently working on a digital transformation strategy to improve efficiency across the production and supply chain. Last year, the company began the implementation of better telecommunication systems, information security, application optimization, and cloud migration, but is yet to address the challenges of predictive analysis, facial recognition, and big data. Logity is a company dedicated to developing integral solutions for the part of custom logistics. With the use of IBM's Watson technology, the company has managed to reduce cost and times exponentially in custom operations and thus plans to reach a 20% market share next year. Kaiso is an agri-tech startup that uses geolocalization to perform metadata analysis of soil, pH levels, humidity, temperature, and overall weather conditions. The technology enables farmers to automate irrigation in response to weather conditions. This has optimized crop outputs by 54% in comparison to current processes. Kaiso is training and piloting the algorithm in Milpa Alta, Mexico City and Cuernavaca, Morelos, and working closely with local farmers. In a joint venture with Amazon Web Services, Siemens, at its plant in Monterrey, Nuevo León, provides a use case for specialized monitoring of low-voltage equipment in the energy sector implementing MindSphere. The tool facilitates real-time monitoring of the parameters that make up the calculation of the effectiveness of the equipment that represents delay in the production processes. providing engineers with the necessary information for effective decision-making improvement actions.
Let's make some conclusions. Mexico is a world within itself. The variety of patterns arising from the interaction between the economic and environmental ecosystems position Mexico as an ideal location for data harvesting and training. Data hub networks that harvest, classifies, and orchestrate open data and enriched data could make the foundation of a dynamic digital economy. This is possible because cumulative networks increase the technological level of any industry or sector. Also, with high-quality data and low-cost data, machine learning could take network models to global scale and change the current social structure. How can we make this possible? As a perspective, we may be able to improve data models from the pure science using Mexico's natural laboratory.